Welcome to Westover Scientific's presentation of Inspect Before You Connect, and Introduction to Fiber Inspection and Cleaning. Westover is the industry's leading supplier of optical connector inspection equipment. For over 10 years, we've worked with the largest telecommunications companies in the world to understand and overcome the problems associated with contaminated connectors. In doing so, we've had the privilege of learning from some of the best process engineers in our industry. Along the way, we immersed ourselves in both the inspection and cleaning process, as well as the science that underlies how contamination can affect signal performance and connector longevity. Today, we use this experience to help optical equipment manufacturers, service providers, premises cabling companies, military organizations, and the aerospace industry. We develop application-specific hardware and training programs to implement a proactive inspection and cleaning program that can dramatically lower costs and improve yields.
Hello, I'm Craig Black with Westover Scientific. The purpose of this video is to pass along some of our experience with cleaning and inspecting fiber optic interconnects. Westover makes a comprehensive line of industry-leading inspection systems, and we also offer a line of precision cleaning systems for high-volume applications. Implementing a discipline for effective inspection and cleaning is more important than ever. Laser power, bit rates, and bandwidth have driven the requirements for cleaning to much higher levels. In order to provide some context to today's presentation, we'll need to review some fundamental aspects of fiber optic interconnects before moving on to inspection and cleaning. Let's start with the problem of dirt and the significant impact it has on our industry today.
You may be wondering why it is important to inspect before you connect. What is true of all optical interconnects is that contamination on the core will block light and reduce efficiency, thereby increasing insertion loss. Further, when that light is blocked, some light will be reflected back toward the source, increasing return loss or back reflection. In some cases, dirt near but not right on the core can lead to an air gap that will also introduce back reflection. Lastly, if the interconnect relies on physical contact, any dirt trapped between the two mated surfaces will damage the glass interface and can become embedded, requiring repolishing to repair it. To illustrate this point, consider this analogy. Imagine these drinking glasses represent the ends of a fiber connector. Now look what happens when these two glass surfaces come together with a pebble in between them. This is what is happening when you make two glass fibers together without first ensuring they are clean.
Today, contamination is the #1 problem in troubleshooting optical networks and equipment. The importance of inspection and cleaning is now commonly recognized across the industry, from Tier 1 manufacturers to the largest service providers in the world. However, while this information is widespread, most companies still inspect and clean only after a problem is found during system test or troubleshooting. We call this reactive inspection and cleaning because it's done after the connectors have already been mated. Tier 1 providers estimate that at least 40% of troubleshooting optical connectivity is simply a result of dirty connectors, making this one of the most costly problems associated with fiber deployment and major source of delay and downtime. A little dirt really can impact your bottom line. Today, the most progressive companies mandate proactive inspection and cleaning prior to mating the connectors. These companies have done so for two primary reasons. First, proactive inspection and cleaning is proven to drastically reduce troubleshooting time in manufacturing and field installation. Second, a proactive approach ensures that you're able to protect your company's assets by minimizing damage from mating dirty connectors. Beyond these tangible savings, perhaps the strongest motivation to inspect before you connect comes from the added ability to control manufacturing and make the deployment process more predictable. There are a number of actual cases where proactive inspection and cleaning would have saved companies considerable time, money, and resources. For instance, a Tier 1 service provider deployed fiber to the home and connected customers with voice and broadband internet. In doing so, the installer paid little attention to fiber cleanliness. The customers were initially pleased with the service until 2 months later, when video was switched on and the service would not turn up. In troubleshooting the problem, the provider had to go back and clean every connector between the customer and the central office. Once the last connector was cleaned, the system turned up without further effort. Had that provider proactively inspected and cleaned each connector during the initial installation, they could have avoided losing valuable time and money in deployment, troubleshooting, and dealing with unhappy customers.
To discuss an inspection and cleaning regimen in detail, we'll need at least a basic understanding of optical interconnects. Today, optical interconnects are most commonly found in two forms: physical contact fiber optic connectors and non-contact lens-based interconnects. Within these categories, there are a myriad of different designs and layouts. For the purposes of this video, we'll discuss three of the most common types: single fiber connectors, ribbon fiber connectors, and the lens elements commonly found in transceivers. You'll need a basic understanding of these structures in order to inspect and clean them properly. Simplex and ribbon connectors are typically physical contact connectors where one or more fiber optic cables are mounted within a ferrule, and that ferrule is mated against a matching ferrule with light spring pressure. This pressure holds the two fibers against one another to maximize efficiency of light transfer. Simplex connectors feature one fiber strand, typically in a round ceramic ferrule, while ribbon connectors utilize a rectangular ferrule with an array of multiple fibers. Both of these approaches require excellent alignment, positive physical contact, and a pristine end face condition to deliver a high-efficiency interconnect. In contrast, many transceivers today utilize a lens system to focus light into or out of an optical connector to couple light with an emitter or detector. There is no industry standard for how the lenses are arranged within these systems, and as a result, you will find different configurations in practical use. Generally, they employ a ferrule stop to locate the fiber in a known position, and lens element to focus the light from the fiber onto a detector or from an emitter onto the fiber. Some systems employ a flat lens that physically contacts the fiber as opposed to the ferrule stop.